for joining us. And we're going to be covering TDD and the Terminator, an introduction to test driven development. A little bit about me. My name is Layla. I am a developer advocate at VMware, focusing on the .NET community. I'm also a GitHub Star, a Microsoft MVP. I live code on Twitch and I'm a member of the Live Coders. And I love C# and especially dogs. And behind me is all the paraphernalia of having dogs in my office normally. No one's here at the moment, so that's okay. But you're probably wondering why TDD and the Terminator. I mean, it's an odd combination. What does test-driven development have to do with killer robots? Well, I'm going to take you back to before I was an advocate and when I worked as a software engineer full-time. And I worked at a telecoms company, and I worked on the platform there for allowing carriers, they're the people who route your telephone call from A to B, to manage their routes and how they were going to direct your calls. So it's a very complicated, very high traffic system. And I was an engineer on that. And we didn't have a single unit test. We didn't have any tests. We actually just had a team of 6 testers. So one did automated testing with Selenium, and the rest did manual testing based on the requirements. We did a massive overhaul of the entire site. We upgraded. We had a whole load of ASPX files. We went up to CSHTML files, so just dragging it forward to a more modern version of .NET Framework and MVC. And we did a whole load of front-end changes, switching over to Bootstrap and things like that. So when we were hands-off, ready to do our release, which we did roughly annually, maybe 18 months, really, really progressive, we handed all of our code over to the testers, and it was about 3 weeks later when we got all of the tests back, and we had a lot of bugs. In fact, 9 weeks of regression bug fixing nearly destroyed my soul. And it was after those 9 weeks that I decided that there must be a better way of approaching software. How can we make software more maintainable and manageable? So I started to research it. And the main thing that popped up and resonated with me was test-driven development. And I attempted to look into it, and I watched videos and I read blogs, I did tutorials, but it all just seemed to be magic, especially when I was watching videos. It was just like, and the tests are green. And I'd be like, wait, what? I don't understand what happened there. And I thought, well, the only way I can do this is to just have a go and try and do it myself. And that's where TDD and the Terminator came from. I am a huge fan of the Terminator movies, so I took T1 and T2 and munged them together to give you my learning path. There is a sequence with some flashing lights in here, so just be aware if you are sensitive to flashing lights. I will give you a warning when they are coming up. TDD successes then. Let's see what drew me to test-driven development and why I was interested. Acceptance criteria. Now, I don't know who has had interactions with product owners, product managers, project managers, and they've gone, yeah, I want the project to do this. And I need this page to display X, Y, and Z. And you're like, okay, so off you go and get it to display X, Y, and Z. And then you show it to the owner and they're like, oh, no, I didn't mean that. I meant it needed to do this and display this data. And you're like, okay. So the thing about acceptance criteria is you have to have all of this clearly mapped out, all of the requirements prior to writing a single line of code. And I love that. Everything is defined. And if the project manager doesn't like what you've done at the end, well, that's what you asked for. So it's a nice comeback. Focus. I think many developers have some form of ADHD or ADD, and as soon as we go and get something off the backlog, we're like, oh, okay, I'm going to do this. But wait, before I do that, I need to do that. But in order to do this, I need to do that. And so on and so forth. And all of a sudden, you're doing what's called shaving the yak. I've got a link to the history of shaving the yak at the end of the talk, so you can find out more about exactly what I mean, and you'll be like, yes, I do understand that. And because you are writing a single piece of functionality to fulfill a single piece of functionality in TDD, you can be very focused and you're not going off here and there and everywhere to do stuff. So it helps keep you very focused and very on track. Interfaces, and you're like, what's that to do with TDD? It's a coding contract. Now, imagine that you've got your teammate and they want to get on with using the code that you're going to be writing, but you haven't written it yet. By creating an interface or a coding contract and writing your tests against that, you are telling that your teammate that here's what I'm going to be producing it. This will fulfill this interface and all of the tests will pass regardless of the code I've written. So they can go on and get on with their code even before you've written a line of actual code, which means you can have asynchronous development, which I love. There's none of that, well, I can't actually get on with this backlog item because I have to wait for so-and-so to finish it. None of that. You have cleaner code because you are writing focused pieces of functionality. You're not like, oh, well, I think I might need this helper library later on. I'll just write that now because I feel like it. And then you end up never using that helper method. So you don't have any of that stuff in there. You just have clean, clear, concise code. Sorry, my mic wouldn't unmute then. We have safe refactoring as well, because we've got tests through everything. If you go and rip the guts out of the implementation of a method and you then test it and it all works, you know it's fine. And if you've broken it somehow, you know about it. And there's none of this huge regression bug generation. So that's a key thing that I really loved. Fewer bugs as well, because you can refactor safely. I know that some of you are going, well, this isn't all to do with TDD, this is to do with unit testing, but we'll get to why the aspect of test-driven, writing tests before code is a good one. Increasing returns as well. It's slow to get going with test-driven development, but once you actually get going, because you don't have so many bugs, you know if your code is passing or not, you can really refactor and develop quickly and efficiently. And the final one is living documentation. It's not a replacement for documentation, but a developer can come in, look at the tests, and understand exactly what your code should be doing and producing without having to dig through stuff or try and reverse engineer it. It's just there. They can read the tests. Right, back to the Terminator. I'm going to talk about the process of doing test-driven development. And we first need to gather the requirements. That was that very first item, acceptance criteria. So we need to go and speak to the product owner or go and research what exactly needs to do. The next frame is going to have flashing lights. So let's have a look. We have a boy here on a motorcycle, and we're looking at their face and we're identifying them and we're thinking, this is a positive match. We need to do something. So these are our requirements that we can determine from that short clip. Scan subjects and determine if they require further investigation, and investigate subjects of interest and determine if they are the target, and then terminate. So let's focus on that first one. Scan subjects and determine if they require further investigation. So the way we want to do this is start with failing tests. And this is really important. And this is where TDD is that little bit different. If you're writing unit tests, you may have already written your code. So you're never going to have failing tests unless you've written bad code. So we use something called the red-green refactor pattern, and that's where we write a failing test. We write enough code to get the test to pass. This is key, just enough code to get that test to pass, and then we refactor. So let's go and have a look at this. And hello, where are you? Oh, we're going that way. Okay, so let me just make this a little bit bigger. I have a simple .NET 6 application here. This is available on my GitHub links at the end of the talk. And at the moment, I have this interface of iSubject, and that requires a subject name. I have an implementation of this model, and I have an analyzer. And this is the interface of it called iSubject Analyzer. And I have to figure out which buttons are zooming. That's what's the trouble when you switch between Macs and Windows. So we have this method here that accepts a subject and returns a bool called investigate further. And then I have my tests over here. I'm using NUnit. It's my preferred testing library. It's up to you what you use. They're all much of a much, but this is my preferred. And in here, we have the thing that we're testing. So it's subject analyzer tests, and then I've got my interface. Remember, we are testing against our interface. And this is a very pragmatic approach to test-driven development. I don't like to be dogmatic. I like it to fit with the way of working. And some people will be like, well, you might not need an interface, yada, yada, yada. This is how I like to do it. And this is my practical approach to working in a team. Now, you may be wondering what SUT is. That's called subject under test. If you have like 10 dependencies in here, everything that you'd be injecting, for example, into a constructor, it can be difficult to figure out exactly which class you were testing. So I always like to call it SUT. That's quite a general practice, and that stands for a subject under test. And then NUnit gives you a setup. So we want to create an instance of SUT. Now you can't instantiate an interface, so we are going to have, and Ryder is going to try and help me here, so I have to remember that. And we don't have anything called subject analyzer. So this is the beauty. We're writing our tests. Let's go and add a new class called not stream subject analyzer. Okay, so in here we have our class. This is now going to need to implement iSubject Analyzer, and it's going to get angry because we need to implement the missing members. So here we have our method investigate further, and it's saying throw new system not implemented exception. And this is perfect. This is where we want to be when we start. So now if we go back over to our test, you can see this is happy, and we can write our first test. Now, there's several ways that you can name your tests. I like to divide them by 2 underscores. Some people will use an underscore to divide each word, but then they get quite lengthy. So let's have a look. They're going to be a public void because they don't return anything. And then we're going to say Terminator should determine to investigate further. Okay, so there's our very first test. So you can quickly go and see Terminator should determine to investigate further. So what do we need to do now? I'm just going to come out a little bit so you can see a little bit more of that. Okay, so there's 3 things you need to think about when writing a test, and that is a range, act, and assert. Now let's have a look at our act first. We want a var result, and this is going to be equal to our subject under test, and we're going to be testing that investigate further method. And you can see that that's expecting a subject, so that's going to go into our range. We're going to have our subject is equal to new subject, and I'm going to give that a subject name. Now let's say we're looking for Sarah Connor, so we want to see a woman. So let's go and look for scanning women in the crowd, we need to investigate them further to see if they are indeed our target. So now we're going to go subject. If we see a woman, we need to investigate further. So using fluent assertions, I am going to go result should be true. Okay. So you can see here straight away, that's our test. And I'm going to ask you just for a moment to think about what's the least amount of code I could write to make this test pass. Just have a quick think, yell it at the screen, and then we're going to go do it. So if you've all yelled at it, I'm going to show you the least amount of code to get that test to pass. And this was a huge aha moment for me. And that is return true. And this was like mind blown. So I'm going to run the tests. Whizzing nyan cats down there. Pending. Oh, it's not found any because we haven't decorated our tests, so it can't find them. So this is another thing about your testing you have to do and decorate them. And you can see it's gone, oh, it's inconclusive. So let's go and run it again, and it should pick it up. And you can see it's success. Now, here you see I'm going to munge my two T1 and T2 together. We're going to write another test, and this one is going to be in case we see a T1000. Now, at the moment, our Terminator is on the same side as a T1000, so we're not going to investigate them further. We're going to let them go on their hunt for John and Sarah Connor themselves. So this time we're going to say determine not to investigate further. This time we're going to say it's a T1000 killer robot. And this time it should be false. So we've done that. And now we've got that. If I run the tests, you're going to see it's going to fail. Let's go in here and you can see we have a failing. So we're going to do that red-green refactor. Let's go back into our subject analyzer. And what I'm going to say that if subject name is equal to, we'll do that dot to lower is equal to woman, then we're going to return true. Else, I don't want those brackets. I don't need them. Return false. Okay, so there we go. That's our basics. Let's go and run our tests again. So this is our red, hopefully green, and we're successful. Okay, now we need to go and refactor once again, and we want to see about doing another test if we see a boy, because it could be John Connor. So rather than do another test here and write it, I'm going to use another nice feature, and this is test cases. So this time I'm going to say, well, I'm on a Mac with a Windows keyboard, so this is just fun and games. So we go boy, and now here you're like, oh, but how do we get this in here? Well, there's a nice little trick with NUnit, and all libraries do it, that we can say I've got a string, and it's going to be called subject name. And now I'm going to pass this in, and instead of just hard coding it here, I'm going to say subject name. Because all of these ones are still going to be determined to be investigated further, we've got true. So now I'm just going to run this. We should see a failing test once again. Let's see. You can see that it's actually expanded that test into 2 for each test case. So then once again, we go back to our subject analyzer, and if I can find this bit, I'm just going to go and grab this, and I'm going to do else if, and I'm going to say boy, and I've got this lovely, if else statement, and then I can run all of these. And everything's green again. So I think you get the idea. Let's go back over to the slides. Okay, so now we're going to refactor. At the moment, we've got this big old if-else statement. Lovely, isn't it? It's there, close enough to what I wrote. And what we're going to do is now refactor it to a switch. Yay! Plain old-fashioned switch, not one of these fancy expression ones. And then we can go and look at all of our test cases. And you can see we've refactored our code. We can still run it. It will still pass. And we haven't had to do anything. But now we've got a requirement change. There's another video sequence coming up. Now, you may be thinking, I've never seen this sequence in a Terminator movie. And I'm going to say, well, you're not a true buff. This comes from the director's cut. So now our T800 can learn, and it's there to protect John and Sarah Connor, not to go and kill. So if it sees a T1000, it's like, wait, we need to be looking at this bot, because the goal is now to protect John and Sarah Connor from threats and an ability to learn. So let's think about if we see that T1000, we've got to go and modify our code. And now all of our tests are broken. Well, maybe not all of them, but we've broken our tests because now our T1000 is there and it's just a pain. So this is where designing your application to be more robust is vital. And to do this, we can employ design patterns. One of my favorite design patterns is the solid principles. I'm not going to go into depth on solid. Don't worry. We'll just go through a little bit of it. And just to remind you what those solid principles are, it's those on the screen right now. But we're going to focus on those first three, the sunny side, as I like to call them, soul, and let's go and have a look. So for the single responsibility principle, every class or module in a program should have a responsibility for just a single piece of that program's functionality. This is vital for you to be able to test a single unit of functionality. If your method is doing loads of different things, you're going to find it really hard to write a test for it. We have the open-close principles. Software entities should be open for extension but closed for modification. Well, we already broke that. We modified our code. So how do we do this? How do we actually change our code and update it without modifying it? I'm going to show you how in a moment. And the Liskov substitution principle, we've already shown that by using an interface, and I can use any implementation of that tested interface, and the correctness of the program will always be there. And that's why I can create that coding contract, give it to a co-worker, and they can get on with code because I'm abiding by this principle. Let's see it in action. So we've got our refactor. Now, the first thing I want to do is refactor our tests so we don't have them split into two. You can see I've got the determine to investigate, determine not to investigate. So let's see. Now I can expand on my test case. I can add more fields and parameters into my test case, and I can change that out. So now you can see I've got a test case has a string and a bool, and that's reflected down there in the inputs, and you can see my outcome now. I've changed to result.equals because I don't know whether it should be false or true. And now I can run that and everything passes. But how do we fulfill the open-close principle? How do we modify and add that T1000 in there without modifying? How do we do that? So this is what we've currently got. And I'll go through this quite slowly because it's a little bit of a, wait, what just happened there? Okay. And we are going to add in a new interface, a new contract, and this is going to be called an subject rule. So we're going to implement a rule set, and I love these. They're great for notification services and all that sort of thing. And this has two methods. It has an is a match, and it has of interest. So the is match is going to match to the case in the switch, and the of interest is going to respond whether it's going to return true or return false based on the code on the left. Alrighty, so let's write a rule for an is woman. So you can see we've got the case woman, it needs to return true. So if we go over here, we go is match, And basically, we're going to write our killer robot based on string matching. Do not do this. This is for demonstration purposes only. Use something like AI, or at least have some kind of tests in there, because like I know this is already broken if I go and look for a man, but we'll ignore that for now. Okay. So imagine this is all perfect. So if we see a woman, we need it to return true. So then we go to the of interest, that returns true. So it's quite simple. Now, if we see a dog, we are not going to go and investigate that further because the Terminator isn't interested in dogs, silly Terminator. So if the match is a dog, we're going to return false in our of interest because we're not interested in looking at it. Alrighty, so now we're going to change our investigate further method to the code on the right. So this is our iSubject analyzer. I'll step through it. So let's bring up the rules so you can see exactly what's going on in here. The first thing we do is create a collection or a list of iSubject rules, so the interface. So now we've got a collection of these, anything that fulfills that iSubject rule interface. And then in our constructor, we're going to new up that list, and we're going to add instances of our is woman and is dog rule implementations. So you can see we've added those instances to our collection. So there's our is woman and there's our is dog. Now they're over to our investigate further method. It still follows the same signature as it did before because it's fulfilling the iSubject analyzer interface. But this time, the innards are different. So what we want to do is iterate over our subject rules collection. And when it returns true in that little bit of, in that link, in that expression, if our dot is match returns true, that is our rule. So now we've got our rule. So this would go through, if we passed in women, it's going to go is match. Yes, it matches, it returns true. Okay, so now once it's done that, we're passing that rule into this little private method. And this private method literally goes and calls the of interest method, which in this case is going to return true. Now, let me just show you, that's a private method. But what if I wanted to test that? We can't test a private method. So if you need to make a private method public in order to test it, then it's time to refactor. Because if we make it public, well, we're testing interfaces, not implementation. So it would need to be added to the interface. But it's a helper method, only helpful to this particular code. The person who wants to use that code, they don't need it. And if you see a lot of methods in a class that look like this, throw new not implemented exception, well, that's a code smell because my coworker doesn't need to know anything about this helper method I have. So they're not going to implement it when they use my code. They're just going to have a whole load of these. So this is where we can use yet another solid principle, which is the interface segregation principle. This splits interfaces that are very large into smaller and more specific ones, so that implementations will only have to know about the methods that are of interest to them. So we would then create an interface of our helper methods. We would test those separately, and then our class here, our implementation of subject analyzer, would implement both iSubject analyzer and iSubject analyzer helpers, or whatever that interface happens to be. Okay, so this is what we've got. Now, if I run the tests, I don't have to refactor my tests. They all still pass because we can safely refactor, remember. There's no problems with that. Okie dokie. So we've got this. Now, one of the problems we had with the previous code was that we had to modify it to add new behavior, and that broke the open close principle. So how do I fulfill that, which is closed for modification, open for extension? Well, like this. I can add new rules to the collection in the constructor. And that is extending my code. I'm not modifying anything. I'm just extending it, adding yet another rule. And we can keep doing that. We can add as many rules as we like to this collection, thus like extending our code without modifying its core functionality. And this was another, oh my goodness, this is an amazing moment for me. Now, you can also add these sorts of collections into your IOC container. You don't have to new them up in your constructor. You can inject collections like this. So there's lots of ways that you can manage it. You can have code that automatically goes and grabs all the implementations of it and then adds those in. But that's by the by. So you can automate this a little bit more or clean it up, and you don't have to even have it in here. It can be in all your startup code. Okay, so we've got this, with good practices, code management becomes infinitely easier. And it's just so refreshing when you go through all of this and you're like, it all just makes sense and I can keep building on what I've got safely. And I hope that you can see how you can build your speed up quickly. So let's have a look at TDD failures. And I think that's important. And one of the main things I think is underestimating the learning curve. TDD is a huge change. It really needs you to think in a different way. And that's not to be underestimated. If you're used to doing code in a certain way, changing your whole MO to this new way takes some work. And it is hard to learn some of these new ideas and this new way of thinking. So confusing TDD with unit testing. And this is quite a big one. It's very easy to go and just write a test. And we could have written a test right in our code and then said, oh, well, I know I'm going to look for a boy now and go and write, oh, well, I'll just do the return true for the boy as well. And, oh, I'll do the return false on other ways. And all of a sudden, you're writing your code first and you're adding unit tests after the fact. And although there's nothing inherently wrong with that, and if you do that, don't go and delete all your code. I have had team leads threaten to delete my day's worth of code because I didn't do it all TDD. I did some of it TDD and some of it just traditional unit testing, writing tests after the code was written. I think that's really dogmatic and unfair because it is hard to change your way of thinking to this. But if you think about writing a unit test after your code is written, you're writing that unit test to fit the code that you have written, not your acceptance criteria, unless you're really strict with yourself. You'll look at the code and you'll write, oh, okay, this here needs to return a 200 because that's what my code says. So you go and write the test and it says, oh, should return 200, yay. But actually, when you go and look at the acceptance criteria, it wants to return a 203. So really, you should have written your test to match the requirements. And that's a hard thing to do. Now, thinking TDD is enough testing. No, we still need like user acceptance testing. We need integration tests. We need all sorts of tests, lots of testing. This is just one facet. And then not starting with failing tests. If you're not starting with failing tests, well, you're not actually, oh, there we go. I went back one too many. You're not actually writing tests first, because if they're not failing, well, there must be code that's passing it. And then not refactoring enough. So being lazy with your interfaces, not testing code, not going through and iterating and getting the bare bones and getting your tests in place. You've got your base functionality and then making it better. And then you're not actually doing TDD. Okay, if you're not doing these sorts of things. Now, implementation within your organization, it can be controversial and is a significant culture change. Do not underestimate this. It is a real big change and people will be mulish about it. They'll dig their heels in and they'll be like, No. Why? Why do I have to do it? Because there is an initial drop in productivity, and that can be really disconcerting to both product owners, developers. People be like, well, we used to do 100 items in a sprint. Now we're doing 10. So you all have to be prepared. You have to have this discussion across all owners, all participants, saying it's okay. We are going to build this foundation, and then we will get quicker, because you will have your productivity rise. Once you've got this foundation of testing framework in there and everyone's on the same page, everything will speed up. Reworks will be reduced. There'll be less bugs. Everyone will be happier. Your customers will be happier. Everything will be better. There is an increased understanding of requirements and their acceptance criteria. So there's no more of your product manager going, oh, well, I didn't quite mean it to do that. I wanted it to do this. No, this is what it did. That was clearly laid out in the requirements. I wrote tests to fulfill the requirements. You're now changing the requirements. And then that comes with a time cost and may not be able to be put in. So it makes people think more about it. But if you take one thing away from this talk, I would really like it to be my aha moment. So when you've got this, write the least amount of code to get your test to pass. This is so vital. And, if that happens to be return true, then write return true. It's really a fundamental switch in the way you approach code. And it means that you're not writing extra code that's not required. And this is the fundamental thing, I think, that people need to understand when doing test-driven development. You just write the least amount of code. Don't get carried away. Don't write other use cases. It needs to pass in the most simplest of ways. And this makes it easier to manage, easier to maintain. Lots of people can come into it and go, oh, yeah, I actually really understand this now. Thank you. So that's kind of my takeaway from it all. If you want to find me on the interwebs, on Twitter and just about everywhere, I am Layla Codes It. You can find more links to more social stuff on layla.dev. If you wish to email me or discuss anything that I've spoken about, you can email me at laylap@vmware.com. And then there's various links to the repos, the deck, my Twitch. I do live code. I haven't been recently because I've been away. And then, of course, if you want to learn more about shaving a yak, there is a link down the bottom. So you can screenshot that. And yeah. Pauline, are you there?
I am. Sorry, I was muted. Thank you so much for that awesome talk, Layla. I think as I was listening to you, I was like, this makes a lot of sense. And I'm actually surprised that a lot of organizations don't understand it or don't talk about it as much. There's a few comments actually there's this really good comment from Jeffrey, who said, I first heard about TDD over 2 decades ago, and I can confirm that I'm still seeing teams that don't do it, don't understand it, and don't see the point. Well, Jeffrey, now you have a video that you can send to your to those teams or anyone else that you come across there. We do have 3 more minutes, so if anyone has any questions for Layla now, please drop them into the chat. I do have one that I thought of. Also, I just wanted to compliment your live coding abilities. Whenever I live code, I'm not nearly as calm. So yeah, I just wanted to say that. So yeah, my question is, what is your maybe number one advice for people who do want to bring TDD to their orgs but have that pushback from everyone?
It's a really good question, and one that I get asked a lot. It's come prepared. If you want to go into this fight, because it is going to be a fight to shift teams over to this, come with reports of how many bugs the team is producing, how unhappy customers are, and why you think the change and the initial drop in productivity that you will have is worth it, and what you can foresee changing. And I think so, you just need to have everything prepared, go through, historical bugs and just go, all of these would have been prevented.
Yeah.
My favorite resources for helping people get started. Um, it's hard because I struggled. So my favorite resource is just tinkering and trying to play yourself. And I know that sounds really weird. Videos on, so I did YouTube, I did blogs, Pluralsight, I looked in books, and nothing helped until I actually did it. Or someone who knows it and pair program with them. I am always happy to help people. On that layla.dev link is a link to my Discord. So if people are stuck and just want some help, you just can't get past it, come on the Discord and I will happily help you.
Amazing. Awesome. Thank you so much, Layla. I think that's all we have for today. Honestly, thank you so much for your time. I hope your jet lag goes soon.
It's
And
passing. It's
oh, thank you.
passing with help.
Oh, everyone has drinks today. Everyone's trying to get through the day. No monster for me, though. Amazing. Thank you
No.
so much, Layla. And we'll be sure to connect with you